water through a fine mesh sieve.
That's a great way to think about it.
You let the pure vocal frequencies flow through, and the heavy, sludgy acoustic mud gets trapped in the filter. It just cleans up the foundation.
Exactly.
So with the rumble gone, we move to step 2, which is the noise gate. The guide suggests a threshold of negative 50 decibels with a ratio of 10 to 1. Let's unpack the math here.
Sure. If the high-pass filter is designed to clean up the sound while you are speaking, the noise gate is designed to manage the audio.
Welcome to the debate. You know, when you step into a traditional professional audio mastering room, there is a very distinct physical weight to the space. You have these massive outboard gear racks, right?
Oh, yeah. The analog compressor is just radiating heat, the thick webs of XLR cables wrapping around the entire floor.
Exactly. And there's usually a heavy-duty workstation tower just whirring away in the corner. And it's doing all that just to process the sheer mathematics of dozens of digital plugins. It is an environment built on heavy infrastructure.
Right.
And for decades, that massive computational weight was simply, the toll you had to pay for professional zero-latency audio processing.
And that physical infrastructure, it exists for a reason. Real-time audio processing is mathematically brutal. If you want high-fidelity sound without digital artifacts, you absolutely need the hardware capable of executing millions of calculations per second.
And doing it without dropping a single frame. Yeah.
Exactly. Which is why our topic today is so interesting.
It really is. We are examining the upcoming release of Ori Eternity, which is an audio application slated to drop between mid-July and August. Specifically, we are diving deep into its completely hand-built audio effects and FX engine.
The core of the software, yeah.
Right. So the central question we are unpacking today is this. Does this on-device, real-time DSP engine represent a fundamental technical innovation in software architecture, or is it simply a highly polished, miniaturized mobile wrapper for the exact same traditional audio engineering workflows we've used for years?
And I've got some strong thoughts on that.
I'm sure you do. Coming at this from the side of a software developer, I'll be arguing that this engine's dynamic web audio node architecture and CPU management are, frankly, a generational leap for mobile audio.
And I come at it from a different way. Bringing the critical ear of a traditional audio engineer, I'll argue that despite the slick mobile packaging, the underlying signal chains and DSP algorithms are purely conventional. They merely replicate standard studio plugins.
So, let's get into it. From a system architecture standpoint, Ori Eternity is just a massive innovation. They have completely abandoned the traditional plug-and wrapper model.
Have they, though?
Yes, they have. Instead, they are utilizing a dynamic web audio node architecture. It's capable of running up to 40 simultaneous audio effects in a single chain directly on a mobile device.
40 effects is a lot for a phone, I'll give you that.
It's huge. And the engine physically detaches inactive nodes from the processing graph to manage CPU load. That structural flexibility fundamentally changes what mobile real-time DSP can accomplish.
See, while I recognize that the CPU efficiency and battery management are incredibly impressive, the actual audio processing strictly adheres to decades-old audio engineering paradigms.
How so?
Well, when you look at the architecture, the developers have organized the engine into 10 collapsible categories. You've got dynamics, repair and clean, EQ and filtering, modulation, distortion, spatial, and so on.
Right, which makes it organized.
Sure, but furthermore, the engine enforces a strict order of operations. You do your cleanup in EQ first, you move into dynamics, you add your modulation, and you end on a limiter. That is exactly, step by step, how I set up a traditional analog rack in a studio.
I see why you think that, but let me give you a different perspective. Putting that massive studio rack onto a touchscreen and making it perform flawlessly without melting the processor requires reinventing the underlying architecture.
But reinventing the code isn't reinventing the audio. Executing standard digital signal processing nodes on a phone isn't a new paradigm. They haven't reinvented audio processing. They've just put my studio rack onto a touchscreen.
But let's look under the hood at how this engine handles processing load. The developers are explicitly stating that this is not a pre-baked filter, it is an internally hand-built live web audio signal chain made of dozens of DSP nodes.
Right. It's rendering live.
Exactly. If you are listening to this and wondering why you should care about a node graph, think about how traditional digital audio workstations operate. If you have a massive effect chain loaded onto a vocal track but you hit the bypass button, The DAW's engine is often still calculating arrays of zeros.
It's idling, yeah.
It is continuously processing absolute silence, taking up CPU cycles just to pass an empty signal through the architecture. Aura Eternity physically severs the connection of inactive components from the audio graph. It completely pauses the background timers.
I'm sorry, but I just don't buy that. Let me tell you why. Bypassing inactive plugins to save CPU is not a new concept in the audio world at all. VST and AU formats have had various iterations of smart bypassing for years in major DAWs.
But not on this level, and not on mobile.
It is standard resource management. Detaching a node from a signal graph to save a phone's battery doesn't change the nature of the signal itself.
I'm not convinced by that line of reasoning because traditional DAWs still operate within a rigid plugin container system. Aura Eternity operates more like a smart grid.
A smart grid?
Yeah. Think of a traditional DAW like a massive mansion, where once you turn the main breaker on, the electrical current is running through the wiring of every single room. Even if the lights are off, the power's there. Aura Eternity dynamically routes the computational power only to the rooms currently in use.
Okay, I see the analogy.
This matters immensely when you look at their advanced audio worklet integration. They have incredibly heavy, computationally expensive effects. Take format shifting, for example.
Which is a very heavy process.
Right. It doesn't just change the pitch of a voice, it digitally alters the perceived physical size of the speaker's vocal tract by manipulating the harmonic resonances in real time. Or look at granular synthesis, which involves slicing the audio into microscopic grains just milliseconds long and rearranging them on the fly.
Those are notoriously CPU-hungry mathematical processes, yes?
Exactly. By ensuring they are completely detached from the processor's memory until enabled, they've allowed a mobile device to punch way above its weight class without thermal throttling. This dynamic routing is an architectural breakthrough.
Doing this smoothly within a web audio API on a mobile device is a great development feat. I won't dispute the coding efficiency. But does dynamically detaching a spectral shimmer node actually result in a better sounding mix?
It allows you to run it in the first place.
But the DSP math itself remains entirely orthodox. To create that spectral shimmer, the software is relying on fast 48 transforms, or FFT. It has to take the incoming audio signal in the time domain, run complex calculus to translate it into the frequency domain, manipulate those frequencies, and convert it back.
Which it does instantaneously.
Sure, but that exact FFT mathematics has been the backbone of digital audio since the 1980s. A highly efficient engine is remarkable, but raw computing power and battery optimization mean absolutely nothing if the person behind the wheel doesn't know how to steer. And that brings us to the actual user application.
Well, that is exactly why the developers lean so heavily into the democratization of these tools. Aura Eternity champions over 150 one-tap presets as a major innovation in user experience.
Presets are a slippery slope.
But for a developer, bridging the gap between complex background logic and end-user simplicity is the holy grail. Let's look at their master podcast preset. With a single tap, the user instantly applies a highly specific multi-stage processing chain.
The one with the aggressive noise gate?
Yes, it applies a noise gate with a -50 dB threshold and a 10:1 ratio to completely kill room tone when the speaker stops talking. It applies a compressor set to -18 dB with a fast 5 millisecond attack to catch sudden loud syllables.
And it ends with a limiter, naturally.
Exactly. It sets up -1.0 dBFS ceiling on the limiter to prevent digital clipping.
That's a compelling argument, but have you considered what happens when you abstract away the necessary nuance of professional audio work? An audio engineer relies on surgical precision, not one-size-fits-all fixes.
But the presets are built by professionals.
Let's examine their acapella focus preset, which you've noted collapses a 7-step signal chain into one tap. In that chain, the preset applies a static 7500 Hz de-esser and a generic 2 to 3 decibel EQ boost in the 2 to 4 kHz range for presence,
which provides immediate professional-grade clarity to the human voice without the user needing to understand frequency bands.
It provides clarity for some voices, but it completely destroys others. Human ears evolved to be hypersensitive to the 2 to 4 kHz frequency range. Biologically, that is exactly where a baby's cry sits.
We are hardwired to notice it, yeah.
Exactly. So if you blindly apply a 3 decibel boost in that specific range to a vocalist who already has a naturally nasal, piercing, or harsh tone, you don't get clarity. You get an ice pick to the eardrum.
Okay, that's a bit dramatic.
It is biological torture for the listener. Furthermore, if you apply a static 7500 Hz de-esser to a baritone voice with a lower resonant sibilant, you completely miss the harsh S sound you're trying to tame. You just end up muddying the high-end air.
But you can adjust it.
But relying on predefined static presets removes the critical listening aspect of audio engineering. It turns a professional tool into a consumer toy where users just blindly cycle through buttons hoping one sounds good rather than understanding the physics of the sound waves.
It doesn't remove critical listening. It provides a significantly higher starting floor for the creator. You don't have to stay locked into the preset. The architecture allows you to toggle and tune those sliders live.
Assuming the user knows what they are tuning.
While you start with the master podcast preset, and if the de-esser is missing the sibilants, you open the repair and clean category and sweep the frequency slider until you find it. What the preset does is build the scaffolding for you.
Scaffolding that is based on standard math.
It automatically sets a 10-band EQ, which is precisely mapped at 31, 62, 125, 250, 500,
And 1K, 2K, 4K, 8K, and 16K hertz. Yes.
Right.
It lets the user tweak from a position of safety. By abstracting the complex routing, but leaving the parameters exposed, it democratizes high-level audio production.
Accessible? Yes. Innovative? No. Standardizing an EQ curve makes it easier to use, but it doesn't change the underlying physics of the tool.
How so?
The fact that the 10-band EQ is mapped to those specific numbers, 31, 62, 125, proves my point entirely. Those are the mathematically standardized ISO octave frequencies. They are spaced precisely by doubling the frequency, which corresponds to how human hearing perceives octaves.
Which is why they work so well.
But the tool is relying on the exact same acoustic math that hardware graphic equalizers have used for over half a century. It is entirely orthodox. That's an interesting point, though I would frame it differently. While the EQ bands follow standard mathematical octaves, the engine goes far beyond just replicating standard voice processing.
You mean the novel FX stuff?
Yes. If we shift focus to the engine's more esoteric and experimental capabilities, the novel FX category proves this is a new paradigm in audio manipulation. They have built a signature chopped and screwed module directly into the engine.
Which is basically just a complex delay.
It isn't just a simple delay. It features dedicated variables for screw amount, chop rate, stutter length, and count, allowing the user to manipulate the sample rate and time stretch the audio in real time. Plus, they have the Aura K Ultra Wellness and Focus processor in there, too.
Oh, right, with the alpha and gamma binaural modes. It is certainly a fun tool for the specific demographic producing slowed and reverber nightcore tracks. It streamlines that specific aesthetic.
He does more than streamline. When you take those novel effects and combine them with the pitch and speed category, allowing independent pitch shifting without affecting the tempo, and route that into advanced spatial effects like the Doppler shimmer, you are fundamentally reshaping the audio in real time.
Okay, but you can do that in a DAW?
In a traditional linear plug-in environment, creating that kind of cascading modulation requires heavy manual auxiliary routing. You're creating multiple buses and balancing wet-dry signals across different channels.
True. It takes some setup.
Blurs the line between a passive audio effect and an active musical instrument.
I will readily concede that blurring the line between effect and instrument is an interesting creative direction. But I will point you straight back to their own documentation, specifically the podcast cheat sheet rule they provide to their own users.
The limiter rule?
Yes. The final unbreakable rule they list is always end on the limiter so nothing clips on export.
Because digital clipping destroys a recording.
Exactly. When a digital signal exceeds 0 decibels, the system cannot represent the sound wave, so it flattens the peaks into harsh, distorted square waves. To prevent that, you must use a brick wall limiter.
Which the app provides.
My point is that no matter how many transgates or harmonic exciters you stack in that novel effects category, the engine remains totally subservient to the fundamental physics of a traditional master bus.
I don't see how that detracts from the software's achievement.
Because the signal still requires proper input gain staging at the front end. It still requires a subshelf EQ to control low-end rumble. It still needs a glue compressor to physically bind the disparate sonic elements together by reducing their dynamic range. And it absolutely must hit that limiter at the end.
But doesn't the fact that this software architecture seamlessly enforces those rules for the user constitute a leap forward?
It protects them, sure.
Right, because in a traditional DAW, if you route your signal wrong, if you accidentally place your limiter before your compressor, or if you put your noise gate after your convolution reverb, you completely destroy the integrity of the audio. The gate will chop off the natural decay of the reverb tail.
That is a very common beginner mistake, yes.
Aura Eternity's architecture prevents those catastrophic user errors by enforcing the correct order of operations algorithmically. Cleanup, then dynamics, then modulation, then spatial, then the limiter. It uses software architecture to guarantee audio integrity.
It protects the user from themselves, which is excellent UX design. But again, we're debating whether this is a fundamental technical innovation in audio engineering. Building a pristine, self-driving vehicle with perfect guide rails is an achievement, but it is still fundamentally relying on rotating rubber tires on asphalt to move forward.
The interface is completely different, though.
The interface might look like a futuristic instrument, and the back-end node management may be brilliantly coded, but the immutable rules of digital audio have not changed one single bit. The engine relies on a ring modulator for metallic sounds, a bit crusher for lo-fi crunch, and a phaser for modulation.
All running seamlessly on a phone.
Yes, but a phaser isn't magic. It is just duplicating the audio signal, applying an all-pass filter to shift the phase of the duplicated wave, and mixing it back with the original to create comb filtering notches. Running that phase cancellation math on a mobile CPU doesn't change what a phaser is. We are still using 1980s DSP math.
I see your point. You are looking strictly at the mathematical output of the signal, whereas I am looking at the structural delivery mechanism of that signal.
That's a fair assessment.
To me, the fact that you can have a full master bus, input gain, sub boost, air, glue comp, limiter, running simultaneously with 35 other nodes on a device that fits in your pocket, without the audio dropping out when you background the app, is a structural revolution.
And that is where I think we find our strongest point of convergence. From an audio engineering perspective, I will never stop defending the necessity of surgical precision, and I will always view these tools through the lens of traditional signal flow. The math is the math.
Right.
But I have to admit, packing 40 simultaneous effects, everything from granular synthesis to multi-band dynamic EQ, into a mobile device without melting the CPU is a remarkable technical achievement.
It really is staggering when you look at the resource load.
The physical node detachment you described, pausing timers to prevent the processor from calculating arrays of zeros, is a brilliant way to bridge the gap between heavy DSP requirements and the thermal limitations of mobile hardware.
It is a feat of engineering. And to summarize my position, that is exactly why I view Aura Eternity's hand-built web audio processing as a massive leap forward.
Even if the DSP math is the same.
Yes, because the dynamic node detachment, the on-device real-time rendering, and the collapsing of highly complex signal chains into accessible presets represent a new era of software architecture. It democratizes high-level audio production, taking it out of the expensive infrastructure-heavy studio and putting it directly into the hands of creators everywhere.
And to summarize my stance, while the software optimization is undeniably impressive, the tool itself is ultimately a beautifully optimized, highly accessible repackaging of the exact same signal flow and DSP techniques studios have relied on for decades.
A miniaturization, as you said.
Yes, the physics of audio compression, EQ frequencies, and gain staging haven't changed, and neither has the math required to manipulate them. It is a fantastic miniaturization of the studio, but it is still, at its core, the traditional studio workflow.
Which leaves us with a fascinating duality. The true value of Aura Eternity, and whether you view it as a revolution or simply a highly polished evolution, may depend entirely on where you are standing.
Exactly.
If you are a developer looking under the hood at the code, Watching nodes dynamically attach and detach to save mobile CPU cycles, it looks like magic. But if you are sitting in front of the studio monitors, analyzing the waveform and listening to the mix, you hear the comforting, familiar mathematics of traditional audio engineering.
It all comes back to that physical space we talked about at the beginning. The heat, the cables, the massive racks of outboard gear.
We've taken that heavy, electricity-hungry room and folded it into a piece of glass in our pockets. The question isn't just whether the tools themselves have changed, but how having that entire mastering room in our pocket changes what we are able to create.